Last category is evaluate logarithms, level 3. So click on that. Okay, so it's kind of similar to level 2. I honestly don't quite know the difference, but well, actually no, I do know the difference. Let's work on this one together. So let me turn on our annotation. And so let's just call this equal to x so we can think of it in exponential form. It's a lot easier to manipulate them in exponential form. So we have 9 to the power of x is equal to, sorry, that's an x, is equal to 1 over 27. Okay, so 27 cannot be rewritten with a, well, it can, but 27 won't really be rewritten with a base of 9. It can more easily be rewritten with a base of 3. So we're going to rewrite both sides so that they have a base of 3. So 9 is 3 squared, right? So instead of 9, I'm going to write 3 squared. And I'm going to keep that x because it was 9 to the power of x. All I did here was replace 9 with 3 squared. And I'm rewriting it with a base of 3 because that base of 3 can be shared with the 9 and the 27. So it's going to help us solve this equation. So 3 squared to the power of x is equal to 1 over, I'm going to keep it as a fraction for now, 1 over, and then 27 is 3 to the power of 3. You can try that on your calculator. 3 to the power of 3 is indeed 27, just like 3 to the power of 2 is indeed 9. So far, I just made 2 adjustments to our equation, and then I just rewrote them in terms of base 3 because they both have a common base of 3. Before we move on, are there any questions? All right, so let's first deal with the 3 squared to the power of x. So remember with the 2 and the x, these are our exponents. We just need to multiply them. So 3 to the power of 2 times x, 3 to the power of 2 times x. So it's just 3 to the power of 2x. And then on the right side, we have 1 over 3 to the power of 3. So remember, here's a fraction. And it's technically just a flipped fraction because it's 1 over 3 to the power of 3. So all we have to do is rewrite this as 3 to the power of negative 3. Remember that the negative exponent means it just turns into the flipped fraction. So instead of 1 over 3 to the power of 3, this is 3 to the power of negative 3. That negative just makes it a flipped fraction. Okay. So now we have 3 to the power of 2x is equal to 3 to the power of negative 3. And so since they both have a common base of 3 now, we can ignore the base of 3 and we can simply focus in on the exponents. So the 2x and the negative 3, they must be equal to each other. Because 3 to the power of 2x is equal to 3 to the power of negative 3. So they both have a common base of 3, and so therefore we just focus in on our exponents, the 2x and the negative 3, and we set them equal to each other. And from here, we can more easily solve for x by just dividing by 2. Those cancel out. X equals negative 3 over 2, and this would be your final answer. And so before I go ahead and type that in and submit it, are there any questions? And then I'm going to type in negative 3 over 2, submit. And then let's do another one. Okay. Wait, oh, wrong button. Okay. I was looking for the annotate button and I just wasn't looking at it. Okay. Oops. Okay. So we have log base 128 of 64, and this is equal to x. So let's rewrite this in exponential form. So 128 to the power of x is equal to 64. So obviously 64 is a smaller number than 128, which means we have to rewrite this so that they have a common base. And off the top of my head, I'm not exactly sure what that common base is, but I think it's maybe 4. So I'm going to just try out things on my calculator and see if 4 can be rewritten as a common base of this. Okay, so 4 is a base of 64. However, 4 cannot be a base of 128. So let me think about maybe 2. So 2 to the power of 6 is 64. 2 to the power of 7 is 128. And so how did I do that? If you saw me on in real life, you would know I used my calculator for that. So it's okay to use your calculator because sometimes you don't just know things off the top of your head. So 2 to the power of 7 is 128. So I just rewrote the 128 as 2 to the power of 7. And then 2 to the power of 6 is equal to 64. So just a little bit of trial and error on your phone with some educated guesses. And I saw that they were both even numbers. So I tried 4 at first, but 4 didn't work. And so then I tried 2 because 2 is another even number. And then 2 happened to work. So you just find the common base. And in this case, our common base was 2. All right, so from here, we just have to multiply the 7 and the x. So this becomes 2 to the power of 7x equals 2 to the power of 6. And now both sides are rewritten with a common base of 2. So it's 2 to the power of 7x is equal to 2 to the power of 6. And so therefore we can just ignore the 2's and just focus on our exponents, the 7x and the 6. They must be equal to each other. And so we can solve for x by dividing by 7. That will cancel out, and x is equal to 6 over 7. And that would be your final answer. So before I submit it, are there any questions and or people need to write? Let me know. Okay, so let's type 6 over 7. Oof, that looks messy. And then submit. And let's go to the next problem. Did we do this one? We did do this one, right? Like this was the exact same one as the first problem. Okay, yeah, so this is definitely our first one. So I'm just gonna see solution and take the penalty of the points, which is totally fine because we've done this problem. It was the same exact problem. I don't know why they gave it to me twice. Okay, cool, let's do this one. Okay, annotate. So let's call this equal to x. Okay, that's really ugly x, but that's okay. So this is 243. So the power of x is equal to 1 over 27. So we're going to have to rewrite this with a common base. And so since I know 27 is 3 to the power of 3, I'm going to assume that 243 can also be rewritten with a base of 3. So I'm going to try that out on my calculator because I don't exactly know 3 to the power of what equals 243, but I will try it out. 3 to the power of 5 is equal to 243. And then 27 was 3 to the power of 3. So we have gotten up till here, and now we can see that there's starting to be a common base of 3 forming. I'm going to rewrite this more to here because I have space here. So 3 to the power of 5x is equal to 1 over 3 to the power of 3. Remember, when you see that fraction, you can turn it into a negative exponent. So this is 3 to the power of negative 3. Are there any questions up till here? So now we have them rewritten with a common base of 3, so we can ignore those 3's and simply focus in on our exponents because our exponents must then be equal to each other. So we have 5x equals negative 3, and we can solve for x simply by dividing by 5. Those cancel out. X will be equal to negative 3 over 5, and this is our final answer. So I'll pause again to see if you guys have any questions. So let me go ahead and type this in. And cool. Okay, so that was it for this category as well. So let me clear all drawings and we'll end the recording here.